We discussed question 5 and question 6 for A-level mathematics paper 1 in May and June of year 2020. For question 5, the equation of a line is given by y equals mx plus c, and m and c are constants. You are also given a curve with the equation xy equals 16. Part A, given that the line is tangent to the curve, express m in terms of c. If the line intersects the curve, they should have the same y coordinates. So for this case, you can substitute y equals mx plus c into the equation of the curve xy equals 16. So you replace y with mx plus c, and that gives you x, mx plus c equals 16. Now distribute this x here, so that's mx squared plus cx minus 16 equals 0. You can move the 16 over as well. That gives you a quadratic equation. To write m in terms of c, take note that the line is tangent to the curve. When the line is tangent to the curve, there is only one point of intersection, meaning that this quadratic must have only one value of x. There is only one root to this quadratic equation. Quadratic equation has one root when the discriminant is 0. So for this case, b squared minus 4ac must be 0 because the line is tangent to the curve. From the equation here, you can see that a is m, b is c, and c is negative 16 from the standard form of ax squared plus bx plus c. b is c, so c squared minus 4a is m, and c is negative 16. That is set to 0. Then c squared plus 64m equals 0. Express m in terms of c, so move c squared over. 64m is negative c squared. Divide throughout by 64, and m is negative c squared over 64. Hence, we have expressed m in terms of c. Part B. Given instead that m is negative 4, find the set of values of c for which the line intersects the curve at two distinct points. When m is negative 4, we replace m equals negative 4 into that equation here. So you have negative 4x squared plus cx minus 16 equals 0. Given that the line intersects the curve at two distinct points, this quadratic equation has two real roots. The discriminant b squared minus 4ac must be greater than 0 in this case. A here is negative 4, B is C, and C is negative 16. The discriminant becomes C squared minus 4. A is replaced with negative 4, and C is replaced with negative 16. This is greater than 0. Then we have the case C squared minus 2, 56 greater than 0. Now you need to find the set of values of the set of values of c, so that this inequality is true. C squared minus 256 That is a difference of squares that can be factored to c minus 16, c plus 16 greater than 0. So from here, you see that the zeros are negative 16 and 16. You can draw a sign diagram for C here. So when you draw the sign diagram for C, the C values are either negative 16 or 16. So you have negative 16 and 16. Now look at the first linear factor, C minus 16. This is positive for values of C greater than 16. So it is positive on this interval and negative elsewhere. For the factor C plus 16, C plus 16 is positive when C is greater than negative 16 and it is negative elsewhere. Now let's look at the product of sign. You have a positive, a negative, and a positive. We solve for the case where the product is greater than 0. So we look at the intervals with positive sign. And in this case, C is either less than negative 16 or C must be greater than 16. That gives you the set of values of C in which the line intersects the curve at two distinct points. Question 6. You are given functions f and g that are defined for the set of real numbers. Fx is given by 1/2 x minus a, and gx is given by 3x plus b. Those are the functions given to you. A and b are just constants. For part A, you are given that g of 2 is 10. So you need to find g of gx first. G of gx is 3x plus b. So you replace x with 3x plus b into the function g. That gives you 3 times 3x plus b here. And you can distribute the 3. That gives 9x plus 3b plus b, which is 9x plus 4b. And you are given that g of 2 is 10. So replace x with 2, you have 9 times 2 plus 4b equals 10. So 18 plus 4b is 10. And 4b is 10 minus 18, which is negative 8. Divide throughout by 4, and b is negative 2. So you have the value of b. Find the values of a. From the second part here, f inverse of 2 is 14. So what you could do for this case is, instead of finding the inverse function, you do that. Then you see that 2 is f of 14. So f of 14, you have 1 over 2. X you replace with 14 minus a. Then 2 is 7 minus a. And a is 7 minus 2, which is 5. Part B. Using these values of a and b, find an expression for g of fx. F of x is 1/2 x minus a, which is minus 5 here. And g of x is 3x plus b. b is negative 2. So you have 3x minus 2. You need to find g of fx. So you have g of 1/2 x minus 5. And for the function g, you look at this x, you replace this x with 1/2 x plus 5. So you have 3 times 1/2 x minus 5 minus 2. Expanding 3 over 2x minus 15 minus 2, g of fx is 3 over 2x minus 70.